snacks using chemistry.
Our snacks for today are some brownies with a twist and some refreshing lemonade.
First, we're making the brownies. So we're pouring the mix into a bowl and adding eggs, oil, and water.
This is an example of a heterogeneous mixture because you can see all the different parts.
As we mix, it becomes a homogeneous mixture because it is the same throughout.
So the ingredients we're using today are some chocolate chip cookie dough, some sugar for our lemonade, eggs for our brownies, some imported olive oil, packed in Italy, some Oreos, and our brownie mix.
First, we need to add in the brownie mix. Then crack 2 eggs.
Ingredients, you have to whisk to a smooth consistency.
As the temperature increases, the molecules in the brownie mix move at a more rapid pace, causing the brownies to rise. This is an example of the collision theory at work.
Because the brownies are in smaller pans, the surface area is smaller, making the brownies cook faster.
The use of a catalyst would speed up the chemical reaction by increasing the rate at which the product is produced.
As the brownies begin to cook in the oven, it shows an endothermic reaction because they are gaining heat from the oven.
As the brownies cool, it is an exothermic reaction because they are releasing the heat to cool off.
Your next step is to transfer the brownie mix into the cupcake or whatever tin you're using.
For the brownies, we notice that the liquid of the mix has turned into a solid.
The next step is to place your Oreo on top of the halfway baked brownie and then put your cookie dough on top of the Oreo. After you've placed Oreos on each of your brownies, you're going to mold your cookie dough into cookie shape and place it on top of the Oreo and fill in the rest of the space.
So this is what the final product should look like right before you put it in the oven. While that's cooking, we're going to make some lemonade.
The solute is what's being dissolved and the solvent is what is doing the dissolving.
The lemonade mix is the solute and the water is the solvent.
Stirring or agitation will make the solute dissolve at a faster rate. As the solute and solvent mix, it becomes a solution.
Molarity is a concentration of a solution expressed by moles of solute per liter of the solution.
In this case, molarity would be the moles of lemonade mix per liter of water.
pH is a measurement of the hydrogen ion concentration of a solution. Solutions with a higher concentration of hydrogen ions have a low pH, and solutions with a low concentration of H+ ions have a high pH.
Lemons contain citric acid, and citric acid is a weak acid. Because of this, lemons have a pH of about 2. So now we're going to be pouring the lemonade mix into our water. So we're going to pour about 2 quarts, which is how many liters? Half a liter. That was satisfying. This is the final product, and conservation of energy states that energy can't be created or destroyed, but it can be altered from one form to another.
The heat is being transferred from the oven in the brownies, and as they're taken out of the oven to cool, the heat is being released back into the air.
Specific heat is the heat required to raise the temperature of a given substance.
As long as there is a temperature difference between 2 systems, heat will always find a way to transfer from the higher to lower system.
Ionic bonding occurs between atoms that have opposite needs for electrons, metals and nonmetals, and the result in a transfer of electrons.
Covalent bonding occurs between atoms that have similar needs for electrons to nonmetals and result in sharing of electrons.
Thanks for watching our video, and
time to eat this
time
good
to get lit.
Cheers.
Cheers,
Cheers, girls.
That's just enough solute.
That's some good concentrate.
This is just the right amount of saturation for me.